Hi, I'm Adam. I would like to introduce myself very quickly. I'm a co-founder of Hamza and the moderator. So I would like to introduce Hamza up front. We'll start with the talk right away. And there he is. Hi, Hamza.
Hi, Adam.
So, Hamza, you were a software engineer by training. You did your master's in Munich in applied AI. And you turned to be an ML engineer with experience of more than 6 years. We are super happy to see how far you got, what you did, and what problems we can solve in the future. But before you start, sorry, I have some organizational intros. So when you double click on the slides, then they maximize. So you can really choose which window you want to have. And during Hamza's talk, you're invited to type your questions into the chat, which I will then ask Hamza in the end. So that would be cool if you can already start with doing that, that we don't have too many in the end and miss some of them. In any case, you can write an email to Hamza. Hamza's email address is on it, and I will just push it in the chat now and would give the mic to Hamza. Have fun. Thank you.
Excellent. Cool. Thank you, Adam, for that wonderful introduction. Hi, everyone. Hope everyone's having a great time at the conference. I think there have already been some really cool talks. My name is Hamza Tahir. As Adam said, I'm the co-founder of Adams at maiot, which is a company based in Munich, Germany, and working actively in the MLOps space, actually building an MLOps platform to solve some of the problems that I'm going to talk about today. Which brings me actually to the title of the talk and why I think machine learning in production is still broken. And I'm super excited to also get your questions and opinions about it. Obviously, it's a very opinionated discussion. It may be polarizing, but I'm looking forward to feedback. Okay, so let's begin. So it's very natural that I start off with the hidden technical debt paper by Scully from Google. I think everyone's seen this to death. I don't want to talk too much about it, so don't worry. It's not going to be another talk where I talk about these boxes that you've seen for 5 years. The reason for putting this up actually is to just illustrate that since 2015, we as an industry have known that machine learning is in production is quite hard. And we also know that the machine learning part is actually very small. And when you come from university, for example, you expect that this little black box is going to be big, but is actually not that. So the surrounding peripheral things are taking most of your time. And I say this because we know this since 2015, and we've made huge strides since that time, but we're still not quite there yet. And that's what I want to focus on today. Now, accumulated technical debt and the complexity of a machine learning system in production has led to 87% of machine learning projects never making it into production in the first place. I know this is a polarizing figure in itself. Iguazio just a few minutes ago was saying 80%. The point is, it's not about the exact figure. Imagine if 80 or 85 or 90% of Android applications that were developed were never pushed into the Play Store. That would be a disaster for the Android community, right? So I'm not saying it's a disaster for us. Obviously, it's still a young field and MLOps is helping. But we all know, I think the audience can agree, that most machine learning projects really do not live to see the light of production. And my reasoning today is that the complexity of deploying a machine learning application in 2020 in production is still so high that most teams end up deciding it's really not worth it, or they're not fast enough to get value in production to convince the relevant stakeholders to keep going. Okay, so if we talk about technical debt right now, it's not a new problem, right? We know how to manage it. Like, people have been doing this in software engineering since years. The DevOps movement has pushed it along. And we know how to handle really complex systems. So the way we do it is we write tests, we make better abstractions, we refactor code, we make an attempt at better documentation, although that's probably the hardest. And we try to improve the system design. And all of these are super relevant for machine learning. We should do it, right? And actually, a lot of people do this. However, my reasoning here today is that there must be a reason why just these things is not enough for machine learning. And my hypothesis is that there's something in there that makes it super hard to actually solve or resolve technical debt with the complexity of a machine learning in production system. So let me talk about that difference. In my opinion, in traditional application development, the only thing that affects the behavior of a system directly is the code, right? So if you make a change of some code, something changes in a web application or an Android application. And the output of a system could be data, for sure. In machine learning, not only is the code a first-class citizen, and we have to take care of it, also the data itself affects the behavior of the entire system, right? Now, this might seem like a small thing right now, but data is much harder to deal with than code, right? So think about all the things you do to manage code. You probably do unit tests, you probably do code reviews, you're probably treating code with some form of respect. But when was the last time you had a data review? Well, I mean, they do happen, I guess, but not really. So we have to sort of elevate data to the status of coding, and hopefully, this talk will motivate that. I'll also give you another example of this. So data affecting the behavior of a system can be seen as a dependency. Now, imagine, for example, if you use a pip package in your Python code base, and let's say that's pandas, right? You install it, you use it all over the place. Then pandas comes in and says, okay, from 0.25, we go to 1.0, and we change the way how to create a data frame. Everything breaks in your system, right? And that's called a code dependency. But in this case, PyCharm would probably help you. It would tell you something is broken. However, in machine learning, let's think about it. If you have a feature column for your classifier, and you're using a feature that is being aggregated, maybe it's like a weighted average or something, and your data engineers are calculating it upstream to display to a dashboard, and you're also consuming from it, and you train your machine learning model on it, push it out into production, suddenly some guys decides, okay, now the weighted average is going to be calculated with a different formula. And suddenly everything breaks. It's a chaotic, cataclysmic failure throughout the whole thing, and your machine learning model is now suddenly making predictions you never expected it would. What happened? You had a data dependency. Very similar to a pip package, you had a data dependency, you just weren't taking care of it in that way. And yeah, so that's it really has long debugging cycles, and it's really hard to see them because they can also affect you slowly. Okay, so I'm going to just stick to that point because this is really the crux of my talk. And let's go through a generic machine learning journey, right? And sort of try to see some examples and how technical debt and the complexity of a system can play out in production. All right, let's start with a baseline. We all like baseline models, right? A baseline model could be something you see in university. A baseline architecture, excuse me, can be something you see in university, something you see in a small startup, something you see in a small department in a bigger corporation. And what happens is you have a bunch of static data, you have some Jupyter notebooks that are doing something, you have an exported model at the end, and you have evaluation results, right? And you're iterating on it, and your entire team is working on this day and night because it's a tough enough problem in itself. And your incentive is to get that model out there to convince the stakeholders to let you put it in production, which is what you do. You get your first deployment out, you say, okay, I'm super happy, let's put this in production, the stakeholders are happy. We go out there, maybe we're also in the team, we have the expertise to use Flask or TF serving or something. We put it into a container, deploy it, it's done. Okay, now that's not how it works already, right? There's already a big problem here because you made a lot of assumptions in your Jupyter notebooks that now you have to probably rewrite for that deployment, right? You're gonna take all of the assumptions that you made. Maybe you made a sampling assumption. Maybe you made a pre-processing assumption. Maybe you made some hypothetical assumption that I don't know what it is, but it's scattered in 100 Jupyter notebooks in like 5 different GitLab repos, right? It's hard to assemble that back in and to write it in a code which is a bit even testable. You know, you still want to have some tests. So you do that, you spend a few weeks. I know Igwazio said it takes like months. It could take months, right? And maybe someone else is doing it and the things break and da-da-da-da-da. So you already have the first technical debt paying off. Now, as soon as you get the deployment working, your team is sort of exhausted already. But suddenly you realize that, okay, we have a deployment out live, but we aren't really monitoring it because that data is going to flow back in, right? Again, the classic problem of data dependencies. So you figure, okay, now we're a bit free. Let's spend some resources. Let's build a monitoring system that looks at the input distributions. Let's look at the output distributions and see if they deviate from what we expect, right? That's a simple enough code in Python. Wrap it in a service. Maybe it takes you longer than you expect. It probably will, like full disclosure. And you know, like some of you engineers start building that. Now, one of your engineers says, I don't want to do that. I'm a data scientist. I want to work with data. And now he has to make a decision as well. Because on the left side, you're getting new data in all the time. And you're also getting predictions from your Flask deployment, right? Everything's going back together. The data scientist has to make a decision. Do I use the new data now? Do I use the static frozen pickle that I had locally? Do I warm start my machine learning model somehow? You know, he has to make these decisions. And all the while he's doing that, you know, his evaluation gets more complicated. Okay, that's all well and dandy. You're still, now remember, the incentive at this point is to get monitoring working so things don't break. So you're putting out a fire and you're figuring things out as you go. Suddenly, the next day you get up, you get a call from your project manager. Your model has gone stale. It's not producing the right results anymore. What does that mean? Now, model going stale is one of the most expected behavior you can imagine. 99% of models, the moment they're deployed, they have a certain quality and it starts decreasing. And there could be like 100,000 reasons for that. I'll give you a couple. Let's say the behavior of the users changed. Let's say you had more users. Let's say you were not splitting properly and your machine learning model isn't generalizing, right? Maybe that manifests itself over days and days of predictions. So what you should be doing really is you should be refreshing models over time, right? And you should be going through loops where you figure out the quality drops and retrain. This usually happens 3-week cycles, 3-month cycles, depends on the domain. So you go down and you start, you know, sort of investigating, why did your model suddenly break? Was it like an assumption you made? And then you figure out, oh no, there was a pre-processing script that we had done in a Jupyter notebook that we hadn't been using in production. So suddenly you realize that you have to repeat the exact same steps which you do in your training process in a Jupyter notebook, and maybe the guy's on holiday or something. You have to call them and say, please push your Jupyter notebook so we can get that code out, put it in a pre-processing script before the Flask deployment. Let's deploy them together. Things are breaking. Your users are complaining. It's chaotic. New data is coming in every day. You know, at this moment in time, you see how technical debt is accumulating and you see it, but you're really frozen because you need to solve the immediate problems. And you say, okay, enough of the Jupyter notebooks now. Let's break up the training and eval at least and put them into some repos and, you know, start doing this properly. Okay, so you say that's fine. The next day, someone changes a feature upstream. So what happens is your schema changes. Someone in your company or maybe some of your colleagues have said, now this integer is a float. Why? I don't know. I mean, maybe they just want it to be floats now. But you know, it changes everything. You aren't tracking that. You only find that out when it breaks and your monitoring goes haywire. You get an email every 2 minutes. So again, your production model is broken and you don't know what to do, because now you have to go back, you have to look at your training repos, you have to look at your evaluation results, so on and so forth. Maybe you would now start hiring more people. Maybe you did that before. Maybe you get some data engineers and ops people in. They say the solution to your problems is a feature store. What does that mean? It's just a database, a key value store that you put, and now the serving and the training like batch paradigms are now unified because they consume from the same source. So we don't have these two databases anymore. We have one database. So we're never going to have this problem again. So we say, okay. But now suddenly half of your team is focusing on fixing the deployment. Half of them are working on a feature store. Still more people are figuring out the interactions between these. So you're writing an SDK for your feature store or something. Because you hire data engineers, they say we want tests. Some of your data scientists start writing tests. No one wants to write tests, but especially data scientists. So but you make them do it. Then because you have ops guys, they say, let's use Kubernetes or Spark or something, and Kubernetes to orchestrate it. And you say, okay, I don't know what that is, but let's do it. Then you say, okay, the CSV file is too hard. Let's make an experiment library, right? Let's just track our experiments using some like database which you pay for. Then you say, okay, the training locally isn't working anymore. We need to have an orchestration layer, Kubeflow or something, to orchestrate everything, because we have to deploy training jobs in the cloud. Then you say, okay, we have to make sure that each configuration between all of these components is somehow tracked. The results are tracked, and maybe you make a layer that is sitting on top that is recording each interaction. Then you say, okay, let's make the splitting different from the training. Then you say, let's make the pre-processing different from the training. Then you say, let's have ETL pipelines, and on and on and on. And it's like, the point is, it's very hard, right? It's very hard to do this because at every step you didn't make the wrong decision, but you were solving the immediate next problem, and you didn't have resources to sort of come to an architecture that would have solved the future problems, even if you had known about them. Okay, so that's basically why I think the 87% figure is there, because by the time you convince the stakeholders, by the time you build these things, you're sort of in a position where you have to solve immediate problems, and more than application development, you have to fix them. In application development, you could get away with not writing tests for a while. But here, if something changes because data is affecting it so directly, it's going to break it so badly that you're going to hurt, right? And people only write tests when they hurt anyway. So, right. So what am I saying? I'm saying systems fail in machine learning as compared to traditional approaches, fail much faster, much harder, and silently. And in general, production machine learning is hard because you're not incentivized to solve the technical debt problem at each step of the journey. You do not have the right personnel at each step of the journey. And the tooling is still hard to put together to make you leapfrog in all of this journey. And I'm sure you've all been through this. Maybe I exaggerated a bit, I apologize, but I've been through it, so I can feel it. Now, if I stopped here, I would be a really bad speaker because I haven't given you any solutions. I've just told you everything is really bad. But there is, of course, a lot of hope. Since 2015, we knew the problems, and we made so many leaps in that time. And this conference is actually proof of that. There are 700 people here, at least, that are interested across the industry, across the world. And there are wonderful talks that are dealing with the problems that I spoke about right now in the machine learning journey. And we now know the end goal, right? So this is, for example, a state-of-the-art production-ready machine learning architecture that we've somehow figured out over the years. Like Uber uses it, Google uses it. I know it's a bit high level, but at least we know this is where we want to end up, right? Like rather than this mess that we had before, we know where we want to come to, and we can be a bit smarter about it now. And not only that, but there's a lot of ways to make it easier. So for example, we have great initiatives like Kubeflow, which is taking away the burden of Kubernetes from data scientists who don't know about it, and making a layer of orchestration that makes it easy. And then we have great companies like Tecton, who just raised a lot of money, that are figuring out the data source problem, the feature store problem. So you're taking your batch pipelines and your online pipelines, and you're putting them together in one feature store. You have that built in now. You don't have to make that yourself. There are lots of experiment tracking like libraries. And in the middle, you have the classical three-way split, the data manipulation layer, the training layer, and the serving layer. And you have solutions now for each of these. And even more, you have companies, for example, like our company and our tool, which is putting everything together in a way more easy manner. So to sort of help you get past this journey without having to feel the pain, so you can get from state like the baseline architecture to maybe baseline +5 without having to do a whole lot. So in conclusion, the tooling is getting better, the problems are better understood, and the people are way more educated and wiser about it. So while machine learning in production is still quite broken, as 87% of the models don't make it to see the light of day, it has never been easier to fix. So that's basically my thoughts in my talk. If you're interested in these topics, please get in touch. My email is right there. I'm super excited to hear your opinions in the Q&As. And if you just want to keep in touch and see what we're doing, then we have a blog that we post about these things in further detail than I had time for today. So please visit our blog and email me if you need anything. Now I'm really curious to see what your questions are. Thanks, Adam.
Thank you, Hamza. So great feedback. So the chat is quite active. Thank you very much for your talk. And thank you, Dave. So we would go with some questions. Dimitri was asking data structure and also meaning. Okay, maybe that's not grammatically correct. I just go through it, maybe we get it. Meaning change all the time because the business evolves and systems have to evolve also. In an ideal world, an update of data structure or meaning should be announced to the ML team and the models rebuilt. Then the ML work cycles would have to match systems update cycle. What are your thoughts about that?
Yeah. Let me read that again. Sorry, it's a long one.
Sorry, messed it up.
No problem. So in an ideal world, an update of data structure or meaning should be announced to the machine learning team and the models rebuilt. Definitely, right? You're absolutely right. For example, if a feature changes, the machine learning team should know. But it's not realistic to have that organically happen. Especially in bigger companies, if you're in another building, there's no one going to be emailing you that this is is going to change, or slacking you or whatever. So I think the answer is a mix, that the business needs to understand these problems, and we're having these talks to sort of educate them as well. But they also need to invest in tooling to make this a smoother process, because at the end of the day, tooling and a culture shift happens together, and tooling makes it easier to have a culture change. So they go hand in hand. And that's why I think the businesses should, of course, business change, right? I mean, but they change in traditional application development as well. But it's not like you're not going to pay for PyCharm Professional if your developers need it. And now we have tooling which will help solve this, for example, feature breaking problem or business changes and sort of tracking all the metadata. And I think that you're absolutely right. We should keep a track of that. And my suggestion would be to use tooling as much as possible and as quickly as possible. I hope that answers the question, Dimitri.
Cool. Dimitri, if not, just write again or go get in touch by email. So the next question, Hamza, would be from Fatin. Can you go into more detail about the framework and solution to resolve these issues?
Yes. So you can still see my slides, right?
Yes, the last slide right now.
I think he's talking about this, that, like maybe talk a bit more about what tooling to use perhaps here. Now, I didn't intentionally go into a lot of detail about each part because everyone solves it differently, and there are a whole bunch of tools available now to solve them. But I can talk, as I think you all also asked, a bit generally. So one big thing that is coming up right now is the topmost layer. Everyone understands that even if you have data lakes and warehouses and everything, there should be a concept in your system known as a feature store, which has a per feature understanding of what the data means. So it's not just a database, as I suggested maybe in the talk, but it has some automations built in to understand how statistically how data is changing. So because each column is like a dependency, right? So at the top, you have lots of solutions. I guess there's, yeah, for sure, like Tecton is one. And then you're using Hive a lot for this, and DynamoDB. So you can go in that direction. There's also an open source one called Hopswork. So you can start with that. I think that's probably the most like critical, because it's going to unify at least what you're training sources from and what you're serving sources from, and the drift between those two are going to smooth out automatically. I would suggest the orchestration layer, the bottommost layer as well, to have from the beginning. It's easier than ever to use Airflow and Kubeflow, and there's things like TFX which help you make it even easier. I would suggest to have the orchestration layer there from the start, even during experimentation. So when you're, honestly, it's going to be a polarizing opinion, but please get away from Jupyter notebooks for a bit. I'm sorry. Please don't be mad at me. I also use Jupyter notebooks, but in production, it's very hard to crack. So if you're going to write a machine learning training job, wrap it up in a Kubeflow orchestration container or something, or use a tool that lets you do that easily, and do your research and training there as well. There's lots of things in the middle, but if there's a specific question about that, I would be happy to answer. I think there are lots more questions now.
Yes, exactly. I just wanted to interrupt you. Many questions. So I would keep on going with Ryan. He was asking where the 87% quote is coming from.
So this is actually amalgamation of our own experience, and like the people in Munich, I've talked to many and sort of had this little survey, but the 87% itself came from a talk that
they've just posted it, right?
Yeah, they've just posted it. So it's not, as I said, it's not really a figure. Don't nail me down to the 87%. It could be 80, it could be 60.
Okay.
It doesn't really matter, because I think everyone agrees in this conference, all the stakeholders who are coming in, that the majority don't make it into production, and that's really what's important, right? We want that to be closer to 10%. So.
Okay, then next, thanks, Hamza. So Lynn was asking, how can I learn more about the role of a feature store plays the architecture you presented?
You can learn more about the feature store by looking at, for example, our blog or Tecton's blog or Hopsworks blog, who talk extensively about the role of a feature store. In general, it is a central storage area which unifies what gets exposed to your training phase and what gets exposed to your serving phase. It can be built very rudimentarily by just using a simplified database and aggregating your ETL pipelines into that, or there are way more smarter solutions like Hopswork and Tecton that let you do way more than that and even monitor the features. So that's in general the role.
Thanks. Ran is asking how your view to open source tools like MLflow is.
Great. I think so. Open source tools are great for people who can afford to manage them. In some corporations, I mean, rightly so, cannot spend the time to just spend a lot of resources in managing and configuring and setting up tools like MLflow. But there is it's as a tool, it solves a lot of problems. It helps you build pipelines. Of course, because it's open source, you need to still put some effort to get to, like it doesn't work completely out of the box, right? You have to put some intelligence in it. So there are some solutions which are perhaps like proprietary in the market that you can spend some money to reduce that gap if that's a pain point for you. If you don't want to do that, then please feel free to use MLflow or any other orchestration, experiment management tool, pipelining tool out there.
Cool. Then again from Lynn, Hamza, quite active user, love it. The tool space changes so quickly that our teams hit option paralysis. Is it better to have an opinionated architecture?
Good question. Is it better to have an opinionated architecture? So like Adam, we made an opinionated architecture at the start when we were deploying it, right? So I think that it's natural to go towards things that work for you. And sure, the space changes very quickly. There's a new GitHub repo every week, which is actually a good thing for the industry. I would say there are winners already out there. So if you asked me 2 years ago, I would also be a bit confused on how to answer. But now there's somehow standards emerging, like feature stores and Qflow and Airflow, and in the middle you have like TensorFlow is TensorFlow extended. So like whatever your problem is, whatever your team's skills are, right? You should take that into account. So that's like there's a minimum hurdle for them to learn these, but then just make an opinionated decision. I would say though, whenever you design the architecture, make sure that you leave as much room as possible for technological degrees of freedom. So because like these technologies that you're using might change, of course, but you want to build abstractions, right? In your whole system that exist as concepts and don't really rely on what's running underneath. So define APIs, define interfaces, like how software engineers do it, and go from there.
Okay, cool. Just Nadia in between was asking whether we can share a link to our blog. I will just type it in after the next question, and I would ask you, Hamza, whether you still have time for more questions, because we don't want to.
This is exactly what I want to do. So I'm super curious to answer the questions as much as I can.
Perfect.
I like the last one that comes in. Can we just talk about the last one?
Do it. Just read it out that everyone knows what you're talking about, please.
She's saying, considering the fact that you're in Munich, have you considered adding additional or possibly multiple boxes which are titled beer in the architecture in order to ease the transitions between various boxes and dealing with ML projects? This is a great suggestion. I will go now, change the diagram, and the next talk that I give will have each connection in the middle will have a big fat beer jug and a mass from Munich. Cheers.
Okay, then the next question from Fun. Do you have suggestions on communicating with stakeholders in order to set correct expectations on why pipelines break, as well as what's necessary to fix them?
Suggestions. So I actually don't have any suggestions. So, I mean, I think that I think it's so different in every industry. I was trying to think of a general answer. It really has to depend on your company's culture and like your relationship with your project managers. I would say educate them from the bottom, like make them sit down, see the presentations in these conferences, and give them examples of how things can fail. And okay, here is one suggestion. Link it to a business outcome. Okay, so given them an example, like for example, you can say, hey, what if like Dave, wait, no, that's not a good name. Like what if Adam now changes the ETL pipeline? Our revenue is going to go 5% less next month. They'll listen.
Okay, cool. So Fun just was laughing in the chat. We got his question wrong, but now you named it on your own experience. So this is exactly what you wanted to hear. That's cool. But
Okay.
if it's still not the thing what we should answer, just type it again. Next question would be from Achim. What are your thoughts on handling data drift? What are some practical ways of checking for drift? Any tools, frameworks you have used and recommend?
The one that immediately pops to mind is actually the ones that, so there's a custom component in TensorFlow extended that is called the data validator. And you can give it 2 streams of data and it compares, for example, if you have a training and eval split, and it compares based on a whole bunch of things that could break, and it spits out the anomalies. So schema changes, distribution changes, schema changes, distribution changes. If there's empty data, right? So which you don't expect, or if there's mixed data. So if you have a schema, if you have a column which has a string in there, in millions of rows, it finds those out. So I would say start with that. There's of course many other Python-based libraries that help you do that as well, but I would say start with that.
Cool. I just see an immediate question from Neda, the last one. May you share the PPT, please, the PowerPoint?
Sure.
Sure. Just ping an email to Hamza and we send it to you. That would be perfect. Or add it on LinkedIn or something like that. For sure, the official conference way does work as well somehow, but that's for sure the quickest. Cool. Next question from Julien. Any advice to avoid having to rewrite pre-processing and data manipulation steps when having to serve the model in high speed or low latency online production environment where Python
Python won't cut it, yeah.
Okay, see it.
Yeah. So you're talking, so it depends on how low latency you're talking about. If you have to rewrite in C++, then I guess that's a bullet that you have to take. And unfortunately, you're not going to get away with having to rewrite it. What I would suggest is if it's a streaming environment, what you can do, if you have a stream coming in like a RabbitMQ or like Kafka, then rather than having a system where you make a gRPC call to an exposed model within the stream, there are now ways in Kafka where you can embed the TensorFlow model, right, straight inside the stream itself. So because, if you have a stream and you make a REST call or something, that's an anti-pattern in streaming. So my suggestion would be look into, it's getting way easier, by the way. So you can even embed your model into into that stream itself using these technologies now, especially in Kafka. I know there's an easy way to do it. And once you do that, you can append your pre-processing graph. So tell your engineers to use a system where they write their pre-processing in tensors, okay, and not just like NumPy or whatever. So that's a hit they can take. They know how to write TensorFlow. And then you can append the pre-processing graph to your actual model graph, and you have everything in TensorFlow, which is of course already C++ optimized, and they have these new initiatives which makes it even further optimized. And then you just embed it in there. I think it'll be quite fast. I'm not sure about sub-MS, that's not my specialty, but that would be my suggestion.
Cool, thanks. Next question, Heathcliff. What is the cost associated with implementing this E2E pipeline? Rough order of magnitude.
Cost associated, like in terms of money?
Yeah, I understand it like that as well.
Do you know how to answer that question? Is it like money in order of magnitude?
Heathcliff, could you chat again? Could you type in your question again? We didn't get it quite.
I mean, you can do it. You can do it for free. If you use open source technologies right now, you can build a pipeline with not a lot of hassle for free. But if you're, as I said, only if you can manage it yourself. If you have the resources and the time and the ability to plumb together these things yourself, you can have it for free. And that's that's the cool thing about machine learning. In the machine learning community, open source reigns. Sorry about that.
Nice. So in the meantime, I don't have a question right now. I would like you, Hamza, to very briefly and not salesy explain what you or what we at maiot do. Just in a nutshell.
Right. So where we're coming from is actually, we spent 3 years trying to deploy models in production for the predictive maintenance space, meaning that we were trying to predict in Munich and in Germany, specifically, moving assets failures. So we used stuff like autoencoders, like a lot of deep learning stuff, time series based. And we ran into all of the problems that I talked about today. And we built an internal platform in those years, like I guess everyone does. But we, because we had a lot of ops in our team, it was very ops heavy. We sort of had to force ourselves to use these practices. And last year we decided that we actually built something that might be really cool to share. And if you look at my screen right now, what we're trying to do is we're trying to be orchestration, so a framework that sort of brings together a lot of the components that you see here. So if you use the MLOps platform, so the core engine, what could wait, let me say that again. So if you use the core engine, what you can do is you can connect to a data store, like a feature store, and create a pipeline that spans data manipulation, training, and serving, tracks your experiments and the metadata, and also orchestrates for you. So we're binding everything together, and we built in automations on the application layer, for example, for like distributed training or hyperparameter tuning, that make sure that if you want to have a jump start to this really state-of-the-art production-ready architecture, you can use our tool and sort of have a way into that, which is easy. So we're like a bit like the glue that holds everything together, and we expose interfaces where you can write each part. I hope that was not too salesy and a bit technical. I tried, but you put me on the spot there.
Yeah, sorry. I love that little challenges in between. Okay, cool. I think we had a really, really cool discussion, many questions. But also I would like to end it here and would refer to our website to get in touch with Hamza at maiot.io, connect on LinkedIn, Twitter, and so on. Dave is just asking something in between. As he's the organizer, I read it.
Yeah, we have to read it now.
Dave is asking whether we can end the session with playing the guitar.
Oh, man, no, please. I'm wearing shorts, so I can't get up anyway.
Is it black tie speedo?
Yeah. But if you join
isn't it a fake guitar just to impress people?
Yeah, I just put it up there so that everyone knows that I'm playing guitar. It's like the typical guitar ego.
Great.
Yeah.
Cool.
Thank you very much. Again, I would echo Hamza at maiot.io, our website. Email me for anything. It doesn't have to be about our platform. But if you were interested in what we talked about, I'd be happy to help out.
Okay, now a flood of thank yous coming in.
Prost.
Guys, connect us on Twitter, LinkedIn, and Hamza, and then he will give a prost.
Danke.
Thanks, guys.
Ciao.
Have a nice conference. Thank you, Dave, as well.